Hello, this is Mr. Henry, and welcome to the Module 2 practice test. So, Module 2 is all about Pythagorean theorem, so I would expect every single one of these problems is going to be about Pythagorean theorem in some form, shape, or another. So, get to it. First one here says, a Native American teepee is in the shape of a cone. Okay. It is 4.5 meters tall and has a diameter of 5.5 meters. What is the approximate volume of the teepee? Ah, that's right. There was also volume in this test. So, or I say in Module 2. So we need to know the volume of this teepee, which is a cone. So you'd look at your formula sheet, and you'd find the volume of a cone uses the formula V equals 1/3 pi r squared h, where r is the radius, h is the height, v is the volume, and pi is 3.14. So let's see what happens if we plug in all the information we know. We do not know the volume because that's what they want us to find. I know 1/3 is 1/3. I know pi is 3.4. I know the radius, let's see, it has a diameter of 5.5. A radius goes from halfway to the outside instead of from one side to the other. That's a diameter. So radius is half of the diameter. So in this case, we're going to take 5.5 and divide by 2. So 5.5 divide 2 equals 2.75. So our radius is 2.75 squared, and our height is 4.5. Okay. So this looks like it should just be a simple kind of multiply everything together sort of problem. I do recommend you do the exponent first. So I'm going to take the 2.75 squared first. And actually, can I just... No, this calculator's too big. So 2.75 squared, 7.5625. Times 4.5 times 3.14 times by 1/3. All right. So now I think I'm just going to multiply this whole big thing together. All right. So I'm going to take 1 divided by 3. That gives me 1/3 as a decimal. Times by 3.14. Answer. Times by 7.5625. And I know some of that was off the screen for you, but there it is. Times that by 4.5. 4.5 equals, I got an answer of 36.6. So volume equals 36.6. So what is the approximate volume of the teepee? I guess, oh, I'm sorry, 35.6, not 36, 35.6. So I guess we're going to have to go with letter A. That is the volume that we found. We used the radius of 5.5, the height of 4.5, pi 1/3. I assume one of these answers is what you get if you don't put in the if you don't put in 2.75. If you put in 5.5, you'll probably get one of these wrong answers. So yeah, make sure you use the proper formula. Do your exponents first, and make sure you're using a radius instead of a diameter. Okay, number 2. Says, I'm using the graph below. What is the distance between the 2 points? So from here to there, can I use my straight line tool? I can. All right, here to there. I want to find that distance. That is my x. Now, I see a right triangle I can make here. I can go, oh man, I had the line tool on. Line tool, I can go like this, and then I can go like this, and you see how it makes a nice pretty little right triangle? That's what I'm looking for. I'm looking for a right triangle because we were very good at Pythagorean theorem. So if we count the boxes here, this is 1, 2, 3, 4. This is 5 boxes this way. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 12 boxes this way. We can do the Pythagorean theorem to find out what is the missing side of this right triangle by using our Pythagorean theorem. A squared plus b squared equals c squared. Plugging in what we know. Remember, the longest side, the one across from the right angle, is always the c. It's always the hypotenuse, which in this case, we don't know what that is. The other two sides, called the legs, go in for a and b, anywhere. So I'm just going to put in 5 squared plus 12 squared equals that. Now, eventually, down here in the problem, we would like it to have it, actually it's probably a little higher than that. Up here, we want to have x squared. We want to square root both sides, but I can't really square root this big, ugly mess until I simplify it a bit. So I'm going to do that. I'm going to simplify. So I'm going to take 5 squared, which is 25. That's 5 times 5. 12 squared, which is 144. I'm going to simplify some more. I'm going to add that together and get 169. Now, I can take the square root of 169 and x squared. So now that I simplified this side, I'm ready to take the square root. By the way, we're doing the square root because we want to get rid of this exponent of squared. So the opposite of squaring something is square rooting. So we square both sides. This side, the x squared cancels, and it's just x. On the other side, the square root of 169 is 13. I assume the 17 is what you get if you add 5 and 12, so there's the no-no there. The 169 is what you get if you forget to square root. That's the no-no there. And the 7 is probably what you get if you would subtract those two. I don't know why you'd subtract them, but that's probably how I came up with that distractor. Number 3 says 3 cities are shown below. Which of the following best describes the triangle formed by these 3 cities? So where choices are, it's either obtuse, right, acute, or there's not enough information in the problem. When we did Pythagorean theorem here, we learned that the Pythagorean theorem, this a squared plus b squared equals c squared, this only works if you have a right triangle. These two sides will only be equal if you have a right triangle. If you don't have a right triangle, well, we can actually still figure out if it's acute or obtuse. So we're going to plug in everything we know, those 3 sides of this triangle, into our Pythagorean theorem, making sure we plug the longest side in for the c. Remember, longest side for the c. So 175 squared here, and my other 2 are both my a and my b. So 115 squared plus 143 squared. And I want to know, are these 2 sides equal? If I do the math here and simplify, and I do the math here and simplify, are they equal? Well, let's figure it out. Clear. Start with 175 squared is 3,620. I'm sorry, 30,625. 3625. Okay. On the other side, 115 squared is 13,225. That was 15 squared, right? Yeah, square 15, okay. And then the other one is 143 squared is 20,449. 2449. Okay. Whew. You guys could have done that much easier in your calculator. You can actually just type that thing in and it will do the math for you. I have to add this up still. So this guy plus 13,225. 13225 equals 33,674. So this is not true, which means this is not a right triangle. This will only be true if you have a right triangle. The Pythagorean theorem will only work if you have a right triangle. It didn't work here. That's how I know it's not a right triangle. Now, what is it? Is it acute or is it obtuse? And the way we tell is we look at the longest side, this hypotenuse. Is my longest side too big or is it too small? If it's too big, that makes your triangle kind of really wide open, obtuse. If the longest side is too small, that means your triangle's not open wide enough and it's acute. So let's see, is this number too big or too small? Well, it's supposed to be 33,674 and it's only 30,625. So this is too small, which makes this an acute triangle because my hypotenuse, my longest side, was too small. It was not big enough to be a right triangle. The answer is letter C. Number 4, the Native American teepee from number 1 has a height of 4.5 meters. Yes, it did. And a diameter of 5.5 meters. Yes, it did. If you want the wooden poles to be 1 meter longer than the slant length of the teepee, by the way, slant length is from here down to here. That is your slant length. So if you want these wooden poles to be 1 meter longer than the slant length of the teepee, how long would the poles need to be? Well, so you want this length here to be 1 meter longer than this length. So if I could find out how big this is, I'll call it x. If I could find x from here to here, I would take x plus 1, and that would be the length of my pole. Okay. So how do we find that side? Well, you're probably looking for a right triangle. To find a missing length of something, a lot of times for us, it's going to be a right triangle. It's going to be a Pythagorean theorem. So if I cut my triangle, my pyramid here, I know the height of this pyramid is 4.5. I know from number 1 that the radius of this pyramid, the halfway to the outside, this section, was 2.75. Which means if we do the Pythagorean theorem to find x, and then take x plus 1, we'll find the length of these wooden poles. So we do. Pythagorean theorem, here we come. I know my hypotenuse is x. I don't know what that is. My two legs are 4.5, not 45, 4.5 squared and 2.75 squared. You can do that much easier on your calculator than I can do on mine. I have this stupid calculator, which I'm really starting to dislike because I can't really, it's not really user friendly. All right, 4.5 squared is 20.25 plus 2.75 squared is 7.5625. 7.5625. If I add that together, I get 27.8125. 7.8125 equals x squared. That's a 7. There we go. All right, and now to solve this, we're gonna square root both sides. Get the x by itself, so that we get x equals. If I square root that, we get 5.27. I'm thinking there's a typo, because if that's my slant height and I add 1 meter, I'd get 6.27, and that's not one of my choices. So I'm wondering if I made a typo somewhere. So I'm going to double check my math. 4.5 squared is 20.25. Yeah, that's my radius. So 2.75 squared is 7.5625 plus 20.25 is 27.8125. I square rooted that, and I got 5.27. I guess there's a typo. I don't see a mistake. I'll try a third time. Height is 4.5. 4.5 squared. Yes. Half of the diameter is 2.75 squared. Yes. That plus 20.25 is that. When I square root both sides, all right, well, I checked it 3 times. My math is good. I guess one of these answers is not correct. So we could either way. So this is the slant length of this tent. And if you take that and you'd add 1 meter, then the new length should be 6.27 meters long. would need to be the height, the length of these poles. So I guess all of these are technically wrong because none of them were the correct answer that I found 3 times. Number 5. Frank wants to mail a 6-foot-long bow staff, think of like Donatello from Ninja Turtles, to his friend, but the biggest box he has dimensions of 5 foot by 3 foot by 2 foot, as shown in the image below. Which statement best describes if Frank will be able to mail his bow staff to his friend? So basically, this bow staff, like Donatello, it's just a big straight pole thing. So he just wants to take this big stick and put it inside the box. He wants to know if his 6-foot-long bow staff will fit inside this box that's 5 foot by 3 foot by 2 foot. Yeah, you could probably say, well, why don't you just stick it in the box and figure it out? But maybe he doesn't want to. He wants to do the math first. So let's do this. So his bow staff, the longest distance inside this box would be from a bottom corner up to a top corner. So like from this bottom corner here through the box to this diagonal top corner. And we want to know, is that distance right there bigger than 6 feet? Would this 6-foot-long bow staff fit inside? So we're going to figure this out. So on our figure, we know, or the right triangle I can imagine being drawn here is I can see this side here, down the wall, and then across the floor. This is a right triangle. I know this side is 2 feet. I don't know that. That's what they're trying to find in the problem. And I don't actually know this side either. This diagonal distance across the floor. But we can find that diagonal distance across the floor. This floor right here is a rectangle. If you look at it, it's 5 foot by 3 foot, just right here. 5 foot by 3 foot. And we're trying to find this diagonal distance. That's a right triangle right there. We can find this missing side. We can find the diagonal distance across the floor. And then if we plug that in here, then we can find our C. So if I use Pythagorean theorem, a squared plus b squared equals c squared, using 5 and 3 as my legs, and I don't know, I'll use x as the hypotenuse. 5 squared is 25, 3 squared is 9, equals x squared. 25 plus 9 is 34, equals x squared. Square root both sides, and we're going to get something a little bit less than 6. X equals 34 square roots is 5.83. So this side here, the middle of the floor of this box, is 5.83 feet long. 5.83. And now in this triangle, or this figure, I have all the shapes I need, all the sizes I need. I know this side here is 2. I know this side here is this 5.83, and I can use the Pythagorean theorem to find my C. So I'm going to do that. I have to do a Pythagorean theorem a second time. A squared plus b squared equals c squared. My 2 legs are the 2 and the 5.83, so 2 squared plus 5.83 squared equals c squared. 2 squared is 4, 5.83 squared is 34, equals c squared. 4 plus 34 is 38. And by the way, if you didn't get exactly 34, you get something slightly different. I mean, if you take this guy and you would square it, you get exactly 34. If you just took 5.83 squared, you get like 33.9888. It's very darn close to 4. Simplify. 4 plus 34 is 38. Square root both sides. And C equals something bigger than 6. Square root of 38 is 6.16 feet. So the longest possible distance in this box is 6.1 feet long. Will his 6-foot-long bow staff fit? Answer is yes, it will. So I know it's not C or D because these are both yes, it will be able to mail it. Now, which is the reason? Is it because the box is long enough, or is it because the box's diagonal is long enough? The box's diagonal is long enough. The box wasn't. The box is only 5 feet long, We need it to be 6. Answer is letter A. Number 6. It says here that Euclid has a cone, cylinder, and sphere. All 3 objects are 8 inches tall and 8 inches wide. Okay. There, beautiful picture. Euclid wants to put the objects in order from the smallest volume to the largest volume. What is the order of the objects from smallest to largest? Okay, so we have to find the volume of each of them and then figure out which is the smallest, the middle, and then the largest. Okay, so I guess we start with the cone. Volume formula for a cone is V equals 1/3 pi r squared h. We did that earlier. So 1/3 times 3.14 times by the radius squared times by the height. All right, so for my cone, my radius goes from the center of the circle to the outside, which is half of this distance. If the whole way across is 8, then half of it is 4. My height is 8. So the height of all of these is 8. So now it's just a pushing buttons problem. So 4 squared, I'm doing the exponent first, is 16. 16 times by, I'm just going to start multiplying. 16 times 8 times 3.14 times the 1/3 is 0.333333. My stupid calculator can't do fractions, so I put in a whole bunch of 3's. And that whole thing equals 133.97. 133.97. That is the volume of the cone. Alrighty-o. Now, we're going to do the same thing, but now we're going to do the cylinder. Now, the formula for the volume of a cylinder is, honestly, it's almost the same as the cone, except you don't have this 1/3. So I could have left most of that stuff there just now. Volume equals 3.14 times by the radius, which is still 4, right? It's a circle bottom, and the radius goes from the middle to the outside, so it's still 4. And the height is still 8. So V equals, clear. I'm doing the exponent first. 4 squared is 16. That's 16. 16 times 8 times 3.14 equals 401.92. 401.92. And lastly, we have our sphere. The formula for the volume of a sphere is V equals 4/3 pi r cubed to the 3rd power, where r is still a radius, and the radius is still 4. From the center to the outside is 4, because the whole way across is 8. So V equals 4/3 times 3.14 times by 8 cubed. So my calculator, I'm going to take 8 cubed first, which is 512, times 3.14 times, now I can't do 4/3 as a fraction on here. You can. I'm going to type it in as a decimal. It's 1.333333333333333333 equals 2,143. Volume equals 2,143. And I'll be honest, I'm a little bit skeptical of that answer, just because it's so much bigger than the rest. I just want to double check my math here again. So I'm going to take 4 divided by 3. Yep. Times by 3.14. Yep. All right. And times by 8 cubed is 512. All right. I double checked my math. It all worked out. So from the smallest to largest. The smallest was, well, it's actually in order. The cone was the smallest, and the sphere is the largest. So cone, then the cylinder. No, not that one. Cone, cylinder, sphere. It was letter A. I found the volume of each and ranked the volumes from least to greatest. Number 7, open-ended. The image below shows a circle inscribed in a square. Yes, it is. I see the circle in the square. The diameter of the circle is 12. diameter is 12. What is the diagonal length of the square? So I'm being asked to find that. Okay? Show all work. Well, if this diameter is 12, like I have it drawn here, that also means that the bottom side of this square is 12. Because the square, this side is 12. You go, why? Yeah, cool. Why? How's that help me? Well, if I erase this middle line now, the diameter of this circle, do you see what shape I just drew? It's just a right triangle. This right triangle with side lengths of 12 and 12, and that's the hypotenuse. So if I do Pythagorean theorem here, I can find the missing length. I can find the diagonal distance of the square. A squared plus b squared equals c squared. 12 squared plus 12 squared equals c squared. 144 plus 144 equals c squared. 288 equals c squared. And I don't know what the square root of 288 is off the top of my head because we'd have to square root both sides to cancel out the c squared part. So c equals, calculator, 288 square root 16.97. So the diagonal length of the square is 16.97 inches. Okay. Now it says two circles with a diameter of 12. Each of these has a diameter of 12. Are sitting inside a rectangle as shown. What is the diagonal distance of this rectangle? Well, that's kind of the same problem. Watch this. If I take this guy, slide down here, and this piece, this height of the rectangle is 12 as well, and it's asking me to find the diagonal distance of the rectangle. It's pretty much the same thing. The only difference is now, instead of this bottom side being 12, it's, well, 12 and 12 makes 24. So it's the same sort of problem. So I'm just going to go into speedy math wizard mode, and here I go. A squared plus b squared equals c squared. 12 squared plus 24 squared equals c squared. 144 plus what is 24 squared? 576 equals c squared. C squared equals, that is 600, 700, I don't know. Let's not do the math. 576 plus 144 equals 720. And now to get the c squared gone, we're going to square root both sides. And we get the square root of 720 is 26.83. Okay. So that is the longest side, the diagonal distance of this rectangle. Number 8, an isosceles trapezoid. In an isosceles trapezoid, the lengths of the base are 8 and 15. The length of each non-parallel side is 5. Find the length of the height, which you don't need to say that. Just find the height of the trapezoid. Show or explain all work. Okay. So we need to find this. I see there's a little right triangle here. If only I knew what this side was right here, I could just say that, like use the Pythagorean theorem with this and 5 and x, and I could find my missing side. So that's going to kind of be my goal. I'm going to try to find out what that piece is. Okay, so I've got this side is 8. Check this out. If I cut this right here, this inside shape, this shape right here in the middle, is a rectangle, which means from here to here, if this is 8, then this part is also 8. So this is 8 right here. That means between these two small little leg pieces, which includes the one I'm looking for, those two together, those two pieces plus 8 has to equal 15. Right? This guy plus 8 plus this guy has to equal 15 the whole way across. So if we took 15 minus 8, that gives us 7. And if we took the 7 divided by 2, cut it in half, each section is 3.5 big. All right, so I'm going to double check because I want to make sure I'm right here. I think this is 3.5 and this side is also 3.5. That's half of 7. Calculator me. 3.5 plus 8 plus another 3.5. Please tell me that's 15. Got it. All right, so this whole side here is 15. We figured out because this middle section is a rectangle that this is 8, and then my other two pieces would have to be 3.5 to make the whole side add up to the 15. All right, so now when we do what we said we were going to do, the Pythagorean theorem here, let's use red. So now I'm going to do a squared plus b squared equals c squared. Make sure you plug the longest side in for the c. So this is your 5, is the c. And then the 3.5 and the x are your legs. So 3.5 squared plus x squared equals c squared. All right, do what you can. I know this side is 25, and I do not know 3.5 squared, so I calculator it for me. 3.5 squared is 12.25. I cannot square root this because I have this other thing next to the x. I have to have it like just as like x squared equals 25 or x squared equals 19, something like that. So I'm going to get rid of this piece. I'm going to solve my equation, get rid of this piece that's not attached to the variable by subtracting 12.25 on both sides. So this cancels out. And x squared equals, what is 25 minus, oopsie, 12.25, 12.75. All right, all right, all right. Now we can square root it. Let's do that. And that gives us x equals, big ugly mess, 3.5707 blah, 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 blah. 3.57, I say is good enough, inches. And if you're not sure if this works out, you can always take 3.57 squared plus 3.5 squared. Does that equal 5 squared? You can check it. 3.57 squared plus 3.5 squared equals 5 squared is 25. That's awfully darn close to 25. I think we got ourselves a winner. So that is the length or the height of this little ugly trapezoid. Last one. Nice. David is setting up a display at Walmart using soup cans that are in the shape of a cylinder. He has used 200 soup cans, each with a height of 5 inches and a radius of 1.5 inches. What is the combined volume of these soup cans? All right, so a cylinder is this shape. And the volume formula for a cylinder is V equals pi r squared h. And it says that he's used 200 of these things that are 5 inches tall and have a radius. I like the radius. I'll draw it in here. The radius is 1.5. So I kind of just labeled everything that it told me in the problem and just got my thoughts organized. So now let's do this. So what we're going to do is my plan is to find the volume of one can. And then when I have the volume of one can, I'm going to take that times by 200 to find the volume of 200 cans. So here's one can. Here's the volume formula. Let's go to town. Pi is 3.14. My radius is 1.5 squared. My height is 5. So x, do this. Let's see, 1.5 squared. So I squared my radius. I did 1.5 squared times 3.14 times, what was the height? 5 equals 35.325. Volume equals 35.325. That is the volume of one can. So now if I take that times by 200, that will give me the volume of 200 cans. Times by 200 equals 7,065. So the volume of 200 cans is 7,065 inches cubed would be the unit on that. So volume of 200 cans is 7,065 inches cubed. After setting up the display using soup can, David now needs to set up a fish tank in Pet Supplies. The fish tank is in the shape of a sphere with a radius of 12 inches. That's what it tells me. He started by putting in one bag of gravel that has a volume of 1,000 inches cubed of gravel. Okay, so he put in here 1,000 inches cubed of gravel. How much water does David need to add to fill the tank up to the top? Okay, so here's what I'm imagining. So not quite sphere, but he has this fish tank. He put some rocks on the bottom. That's worth 1,000 inches cubed. And now he wants to fill the rest of the thing up with water. We need to know how much space is left over. So if we find the volume of this thing and then figure out 1,000 plus what gives us our total volume. 1,000 plus how much water is the volume of the sphere. All right, so volume of sphere, V equals 4/3 pi r cubed. 4/3 times 3.14 times by the radius, which it said was 12 cubed. Calculator me. 4 divided by 3, 1.3 repeating, times by 3.14 times by, I'm just going to type in 12 3 times, times by 12 times 12 times 12 equals, so this is the volume of the whole tank, 7,234.56. 7,234.56. Yep, just make sure I wrote it correctly. All right, so the whole thing, this whole volume is that number. If 1,000 of this is rocks, how much is left? How much water do you still need to add? Well, you'd add like 6,000 something or other, right? If you subtract 1,000 from here, you would have 6,234.56 space left for water. Inches cubed of water. And there we have it, ladies and gentlemen. Module 2 test is done. Thanks for sticking around, and have a nice day.